So, good morning once again. Welcome to SOS webinar. My name is Miriana and I will be your admin during this webinar. So, welcome to this webinar. The topic is how to make your product wireless with IQRF. And today's presenter will be Mr. Hudaba and Mr. Masti. Also, this webinar will be recorded, so you can find this presentation on SOS Web about a week after this webinar. At the beginning, a couple of organization information. Please, if you have any question regarding the WebEx, answer is this question to me, to admin. And if there is any question for our presenters, please address it to Q&A window, and during the webinar they will be answered. Also, I would like to ask you if you have a couple of minutes at the end of this webinar. There will be a short survey about this webinar. If you can provide us with your feedback, we will be really glad and thankful for it. And also, I would like to present you a special offer which will be lasting 1 week, and it will be a special price for development set DS-Star3 from IQRF. And after this webinar I will send you an order form, and if you would like to order, just fulfill this form and send it back to me. So, or if there is any question regarding this offer, you can also ask me anytime and I will provide you with more information. So now I will pass on to Mr. Hudaba to start his presentation. Good morning, Mr. Hudaba. Can we hear each other?
Hello, this is Simon. Can you hear me?
Yes, I can hear you. So I will change the role and you can start your presentation right now.
Okay, perfect. Thank you very much. Once again, welcome to this webinar, which will be fully focused on the IQRF and on the very practical, from the very practical point of view. Some of you, as I saw the list of attendees, have already experience with IQRF. Maybe there are some, let's say beginners. So I believe this webinar will be beneficial for all of you. We will start with the very, let's say, basic things. And then we will go more and more into the detail. But most of the time we will work directly with the IQRF IDE, and in real time I will show you the big picture, what we are doing, what we are planning to release within a few months. Then how you can set up your network, how you can work with your network, how you can work with the so-called Custom DPA Handler. So how you can modify how you can modify functionality of data control transceivers, and then also how you can service your network. So first of all, let me give you let's say a big picture about the IQRF. So what we are doing is actually preparing a platform or technology.
Sorry, Simon, may I disturb you for a second? But we cannot see the presentation right now.
Sorry, can you say it again?
I don't see presentation on the screen.
You don't see the presentation? All right. So you cannot see my screen?
No, not yet.
And what can I do for this?
Please take a button share and.
Oh, there is it. Okay.
Okay, now it's perfect. Okay.
Now it's working.
Hold on, just a second. Yes. Okay, now we can see it.
Okay, thank you. Sorry for this.
Thank you. Okay,
so coming back. IQRF, what we are doing is the technology to make your products wireless, and very simply. From the very beginning, the development is focused on the integration, on very easy integration of our modules into your technology. And as you will see very shortly, it's not only about the modules, but it's also about other things that are around that simplify your process of the development and deployment and also servicing of your network. So basically, IQRF could be used in a lot of type of application. It could be indoor lighting, street lighting. You can use it for thermostatic heads, for heating, for air conditioning. So basically, for any products or any devices where you need to control something, where you need to send commands, hey, do this or do that, switch on, switch off, and so on. So any kind of actuators, basically. On the other side, we can also collect data from some meters, sensors, fire detectors, or even what we have one application, we are collecting data from this huge turbine in the power plant. So even in that kind of application, the IQRF could be used. So it's definitely not a toy. It's really very advanced technology and used in the very difficult environment. So as I said, with the IQRF, you can basically integrate the wireless connectivity within a few weeks. You will see that I will do it here with the basic functions like in a matter of minutes, actually. So the typical applications are usually street lighting, where we don't only switch on and switch off, but the IQRF is used also to collect data from the lamps, like the temperature, the run hours, the kilowatt hours, and so on and so on. The other big applications we've got is in indoor lighting. We have thousands of lights controlled in the shopping malls in Mexico, and basically in one network there are thousands of these lamps that are controlled by the IQRF. Then you have also like home automation and industry automation. All kind of devices could be connected together to control them or to collect data from them. Also metering, that's a huge business which is growing, smart metering, so collecting data from the meters. There's a very important, like the consumption of energy from the IQRF, which is very low. So on the battery, you can work for days or for actually years, not days, sorry, for rather years. Also, different type of sensors. The application is also in the parking system. We have here in Czech Republic in Brno application in the parking where our modules are connected to the sensors that are directly in the ground, and when the car comes, it sends the information, hey, this place is occupied. So this is also one of the typical application. And let's say this this localization system, now we have with SOS very nice pilot project running for Flextronics in Hungary. So actually they want to know where their device is, and with the IQRF you can localize this device. So those are all the typical applications. Like I guess you have your own application in mind, and now let me show you how you can use IQRF in your device. So basically, you have your device, whatever it is, and with IQRF wireless communication, you can connect it to any kind of device, basically. Any kind of device or control machine, I mean computer, it could be also Raspberry, it could be actually any hardware that supports Java. We have a software development kit, and based on the software development kit, you can create your own control device running on Java. The other option is to control the network from the website. From the website, you send with a very simple API commands to the IQRF cloud, and the IQRF cloud is connected to your device through the IQRF. So this is basically the concept. Now I will go a little bit more into the detail. So you have your device, let's say LAN, whatever it is, and you connect what is called data control transceiver. Data control transceiver means that you can control or you can send the messages or receive messages just controlling it with the data. You don't have to write any code. So in these transceivers, there are standard peripherals like a PWM, SPI, UART, and so on and so on. So if you use this, let's say, standard interfaces, you don't have to write any line of code. You can use it immediately. The other benefit of DCTR is that it's interoperable. When you use the DCTR, your devices, I mean different devices like lamp and controller, could be interoperable immediately without without doing any setup and any coding. Also, the other thing is that it's not only interoperable, but it works also in the wireless mesh network with the hundreds of nodes and full mesh topology. Then you need to control this network, right? So you can use the Java-driven device, Raspberry, server, PC, and you connect the DCTR, and the DCTR sends the command or receive the feedback from the network. For this, we have the IQRF SDK, that means Software Development Kit, which is like a pretty big package that has a full Java library that you use in your device, and you can send the commands there and back immediately. We will discuss this. We will discuss the Software Development Kit at the end of this webinar. The other option is to control the network from the IQRF gateways. One of the typical gateway is the USB gateway, and this serves to connect to your computer. That's one option. The second option is to the IQRF IDE, Integrated Development Environment. We will work with this IDE a lot today, maybe like 1 hour. So you will see a lot of features and benefits of this, but it's not only for the development, but it's also for the network management, visualization of the network, and also servicing of the network. Then we have plug-and-play gateways that are going to be released till the end of this year, and this is Ethernet, Wi-Fi, and GSM gateway. You will see it in practice here in a few minutes. That actually you take the gateway, you set it up very easily, and it gets automatically connected to the IQRF cloud, to the server of the IQRF cloud. So without any programming, you get your information, or you can download the information from the server through the gateway to your device. This cloud, or the basic functions of the cloud, is for free. And the other option is that you can buy a license, and the Ethernet, Wi-Fi, or GSM gateway then will be connected directly to your server. That means that we will not have your data on our server, right? So you buy this license, you integrate the IQRF cloud into your server, and then the Ethernet or Wi-Fi or GSM gateway will get connected directly to your server. Then there's a very simple API that you can use from your website or from your PC application or even from the Excel sheet, and send the commands to the cloud. From the cloud, it's sent to the gateway, and from the gateway to the network or to your device and back. So this is the whole package that we've got right now, or that we are releasing in these months. So it's definitely not only about the modules themselves, right? It's about the whole ecosystem that enables you to create your application very, very easily and very, very fast. So this is what we say that it's Internet of Things in practice, right? You can have your device, whatever it is, and connect it through the gateway, through the cloud, to your PC or to your control device, whatever it is. So this is, let's say, the big picture. Now we will go step by step from using the DCTRs, how we actually open the box of the development kit that you can get on the special price, which was offered previously. How you can set up the network, how you can send the commands in your network through the USB gateway, and then how you can connect through the GSM gateway to the IQRF cloud, and how you can send commands directly from your website. Then we will show also how you can modify the functionality of the device and how you can service your network directly from the IDE with a tool called CATS. So if you have any questions, please type them into the question log, and once there are some questions, I will be happy to answer them. Okay. So now let me switch on this webcam. I hope you can see it. So basically, what I've got here is the hardware that we are going to use today. So first of all, I would like to introduce you, if you don't know it yet. the DSTART03. This is the development set that serves for your initial evaluation of the IQRF. If you hesitate if the IQRF is the good stuff for you or not, please order this, evaluate this, and if you like it, keep using it. If you don't like, don't do it. Basically, this is the best thing to make a good decision, I would say. So if you open the box, what you will find there are 3 modules. Those are the modules TR or DCTR, actually DCTR52DAT. That means that they have also the temperature sensor inside. So on the module, there's an integrated antenna, there's a standard microchip PIT, there's also RFIC and other things. Here you have pins to be connected through the SIM card holder, so it's very easy to be plugged in to this. To this evaluation board. So the evaluation board, you have 2 of them there, and there's a SIM card connector, there's a reset button, application button. Here you have the pins connected to the module pin, and also here is a micro USB connector, which serves to recharging the accumulator which is inside. The other thing is, what you can find here is this programmer, CKUSD04A, which is gray, so you can recognize them very easily on your table. And this serves for programming of the modules. So again, you have a SIM card connector, the pins that are connected to the module, reset button, application button, and here is the connector to be connected to your computer. Also, what you will find here is this very short cable that we will use shortly, and here on this flash drive you find the IQRF startup package. Now let me show you what you find in the when you find in the startup package. This is actually this file IQRF OS 305D for this version. By the way, if you want to be sure that you have the really very last version of the startup package, you can go also to our IQRF website, to the downloads, and here you find the IQRF startup package. And here is the very last one. So even if there's a new release, you can always download the last startup package right here. So what you find there are, first of all, the applications for the C programming, if you want to use with the standard transceivers, the data control transceivers, and the applications for the DPA. This is what we are going to work with: custom handler examples and the demo hardware profile. The other thing is that you have here a full package of documentation and the IQRF IDE setup. So again, if you want to be sure that you have the last IDE, please go to the website and download it from there. Here you can just double click and the IQRF IDE will be installed automatically, or you will follow the standard procedure. Only if you have Windows 8, the drivers will not be installed automatically, and in that case you need to follow the quick start guide, where there is in very detail described what you need to do to install these drivers. Then there are other files. So basically this is all you need to work with when evaluating IQRF. So the first thing you can do directly with this DSTART03 is the range test. So basically, if you connect the module, you can see how easy it is. You just plug it in. If you connect, the modules have uploaded application called link. The link works in the way that the module sends out the packet and listen, and if there is not another colleague, I would say, is flashing green. You can see it on the website. So this is a green light. But if you connect another module, actually you can see that now the modules are flashing red. They are communicating there and back. It's basically a ping pong. And now what you can do you can leave one of the evaluation board here, and you can take the other one with you and go around the building or your facility or actually the environment where you plan to have your application, and go there and test the range of the modules. Okay, you see that if I get out of the range, it starts flashing green. If you are in the range, it's flashing red. Yes, the red is good, green is not good. It's because as you can see, the red LED is much more visible than the green one, so that's the reason. So this is basically how you can use the DS starter tree. If you want to work with in the network, let's say, it's better to go for what is called DPA1. DPA1 is a development set which consists of these two development starts. So then you would have actually this hardware available. So 6 modules. I added also tags on them, so we know which module we are communicating with. So this is, for example, number 2. Then in the DPA1, you would have 4 evaluation boards and actually 2 programmers. For our demonstration, we will not use the second programmer and the coordinator, but we will use this GSM gateway. We will use it from the beginning. On the beginning, we will use it as a USB gateway. The installation of the GSM gateway is very easy. You just take the SIM card. This is a standard SIM card with a data tariff, and there are only 2 things you need to know. One thing is the APN of your provider, and the second thing is the PIN of the SIM card. Then you just take it, and in this way you plug it into the gateway. It goes very smoothly. Then you just push this button, and the gateway gets started. Now we connect it to our PC with this USB cable, and basically we have it ready. Okay, so now we have, let's say, the hardware ready, and we will start the IQRF IDE. What you can do is actually go to this IQRF OS, you go to the applications, DPA, demo hardware profile, and here you have a hardware profile demo. So this is a project in the IQRF IDE. You just double click on this, and this file or this program or the IQRF IDE will be open with this project. So what you've got in this project, our task is now to create a network. So here we have demo hardware profile for the coordinator. Hardware profile is actually the standard application. You need this application for the coordinator, and you need this application for the node. The other option is actually to work with the standard transceivers and write your own application in the C language, but then you cannot enjoy the benefits of the DPA data control transceivers and so on. So we are now working with data control transceivers and the DPA protocol. So here you can see you have the plugins here. So here we have demo hardware profile for the node. So I will show you how to upload it into the module. So I take one of the modules, plug it into the CK-USB-04A, the programmer that we have connected to our IQRF IDE. You can see it here that we have connected the CK-USB-04A. Okay, so we have connected there. Now we prepare the node hardware profile, and now we need to prepare the configuration. You can get to the configuration with a double click here on hitting this button. That's another option. In the TR configuration, you can set up the RF band, so you can choose between 868, 916, and 433 megahertz. You can choose the channel. In this case, we have it for 52. The second channel for the wireless programming. Then you can set up parameters of the wireless programming. So this is how you set up the, let's say, the operating system. The other window serves for setting up the hardware profile itself. So here you choose which peripherals you want to have available. This is the list of the standard peripherals. So you can see there are a couple of memories, EEPROM, EEPROM RAM, then LED red, LED green, SPI, IO, we have a temperature sensor, PWM, UART, and FRC. FRC is, by the way, fast response command, and this serves, we will use it shortly, and this serves for very fast download of the data from the whole network. So one thing I want to mention is that you cannot use, for example, SPI and UART at the same time, because actually those peripherals are using the same pins. So actually we will switch them off. Okay, here we can set up the DPA interface for the UART interface, what would be the baud rate. And here, this is pretty important, is that you set up the RF parameters of the hardware profile. You can set up the RF channel for the second network. The second network means the subnetwork. Each of the module or each of the nodes that you have in the network can serve or can work as a coordinator for a subnetwork. And here you set up the channel of this subnetwork. Here is the TX power. The 7 is the maximum. It's from 0 to 7. And here is the RX filter. The RX filter 35 is pretty high. So this is rather for your initial test in a room. Okay. So this will definitely limit your range. So if you want to use it or use the modules outside and test the full range of these modules, you need to go to, let's say, 05 level here. Here, LPRX timeout, this is prepared for the low power modes that are going to be released in the DPA till the end of this year. Here is set up if you want to use Custom DPA Handler, auto exec, and here you can switch off routing. This means that each node of the module can be a router, but doesn't have to be. This is used especially in the cases where you have when you have your devices running on battery. So when it's running on battery, you switch the routing off, so you don't consume the energy of the battery just for the routing. If the topology allows that. So that's the configuration. You can close this. By the way, you can also download it from the module, so you can see how the configuration is set up in this part of the module. So I just close it, and now I want to upload this node hardware profile and this DPA configuration into the module. So I click, I want to upload those two files, and then you can hit F5 or you can hit this button. So when I do it, you see that now the upload is in progress, and we are uploading this hardware profile and the DPA configuration into this module. This is something I've done already for the other modules, so we don't waste the time here. And now I will just plug in the other modules into the evaluation board. Okay, wow. So now we have it ready, and as you can see on the webcam, is that the modules are flashing red. This means that we uploaded the hardware profile, but the module is not bonded. Bonding means that you actually add the module to the coordinator. So the module knows, hey, I belong to the network of this and this coordinator, and the coordinator then knows, hey, this node should be in my network. Okay, so we uploaded the hardware profile for the node into the module. Now we need to do the same and upload the coordinator hardware profile into the gateway. You can see that I will use the gateway in the very same way how I'm using the programmer. So now I will just swap out from the CKUSB04A using this USB device manager to the gateway GSM02 that I have connected as well. Okay, so I just click here, hit close, and now you can see that I'm connected to the gateway GSM02A. Now what I will do, I've chosen the hardware profile for the coordinator, the same configuration. So now I just hit F5 and I upload the hardware profile for the coordinator. That's the only thing that you need to do. By the way, when you buy a GSM gateway from us, the general hardware profile will be uploaded in the gateway automatically. So you don't have to do this, or this upload of the hardware profile. You should definitely upload your configuration if you've changed any parameter. So now we have it ready, and we can refresh. We can go to this IQ Mesh Network Manager, and we can do this refresh. Okay, so now we can see we have only the coordinator in our network, and it's connected to the IQRF IDE. The next step is to go to this control window. Now our task is to add the modules to the network, so do the bonding. So now I will choose, I want to bond the nodes number 1. I will very easily hit bond node, and then I will push the button, this button on the evaluation board. Okay, so I push this, hit the button, and in this way, one after the other, I can bond the nodes. Okay, node 3, okay, node 4, okay, and node 5. So in this way, we bonded 5 nodes, and here in this nodes info, you can see that we have 5 nodes bonded, and this is shown by this yellow or orange color or orange bullet. The next step, now the coordinator knows about the nodes that are in his network, but the topology is not set up yet. So in order to set up the topology, you need to run discovery. Okay, discovery is the automated process. You can set up also the TX power during the discovery, and you can run it, and you can wait few, let's say, seconds. In the case of a small network, it can take a couple of minutes or even tens of minutes in the case of very large network. So now we have the discovery ready, and we can check the topology of the network. So now you can see that we are working in the actual star topology. In order to make the topology a little bit more complex, I will take this package, and I will take the modules, let's say number 3 and 2, and put them into this box, and I will put them on the other side of my table. We will also decrease the TX power, and we will run the discovery again. As we said, we have pretty high filters, so now I should get the topology a little bit more complex than I had it before. Okay, so this is actually the way how you do it. So first you upload the hardware profiles with the configuration, then you do the bonding. That must be in the direct range. However, you can use also remote bonding. So actually add the module at the end of the network, so you don't have to have the node in the direct range with the coordinator, and then you run the discovery. When the discovery, you set up the topology of the network. So now you have the network fully up and running and ready for your utilization. I will put this node back. Sorry for the noise. And now I will show you how you can unbond the nodes. Okay. One option is to unbond the node on the node side as well as on the coordinator side. Okay. So this you will do without untick this checkbox. So now I will unbond the node number 1. I will just confirm it, and you will see the node number 1 started flashing. Okay, so that means it's not bonded yet. Also, we can see it here. The other option is to unbond it only in the coordinator. So now I will unbond the node number 2 only in the coordinator. Yes, and that means that the coordinator doesn't know about the module or about the node anymore, but the module is not aware of this. So the module still thinks, hey, I belong to this module. And now, what you need to do is to unbond this node manually. There's a small trick how to do this. It's also described in our manuals, but I will show you how to do this. You will actually push this button, this application button, and then hit the reset button. Then there will be green LED shining for about 1 second, and when it stops shining, you have to release this application button. Okay, it sounds a little bit complicated, and this is by purpose, not to do it by mistake. So basically, you push and hold the application button, you do the reset, the green LED is shining. When it stops shining, you release the button and the module starts flashing red. Okay, I will show this again on the module number 3. So I will unbond the module number 3 only in the coordinator. So it disappeared here, but the module doesn't know about it. So again, I will push and hold the application button, then I push the reset, green LED is shining, stops shining, I release the button, and the module is unbonded. Okay, so now I will bond them again, which is very easy and simple, and we will have our network up and running again, completely with all nodes. Okay, so now we have 3 orange bullets. That means that they are bonded but not discovered, and 2 bullets that are discovered, so we will run the discovery again. So now we have the network up and running. This is what you would do during your installation. Yeah, so street lighting, you do the bonding, you put the lamps on their positions, and then you run the discovery. Now let me show you how you can actually send commands through the network. It's very easy, and you would use this DPA protocol. So actually you will use these 5 boxes or command lines. The first one is the node address. So the node address tells you which node you want to talk to. So you bonded it as a node number 3, let's say. So you want to communicate with node number 3, so you write here, I want to talk to node number 3. Then the second point is peripheral number. So here you can choose which peripheral you want to communicate with. So it could be coordinator node, operating system, the memories, LEDs, SPI, and so on. So basically the list that we've already seen in the configuration. So let's say I want to switch the LED red here. So it's the peripheral number 6. Then each of the peripheral has a specific commands. So you can switch off the LED or switch on, get state, pulse, and so on. So let's say I will put set on. So this is peripheral command. The hardware profile ID then serves to, let's say, distinguish different types of products. So for example, if you are a member of the IQRF Alliance and you want to put your product on the market, running on the DPA, the IQRF Alliance would give you a specific hardware profile ID, so then you can control only your devices. So basically, then you can have, let's say, lights and temperature sensors in one network, and you can send a broadcast message, and with the hardware profile ID, you would specify, I want to talk just to the temperature sensor, let's say, so you would put here the hardware profile ID. The FFFF means that you are talking to all of them. It's like a broadcast. You are talking to all hardware profiles. And here you have place for your data. You can insert here using the DPA protocol up to 56 bytes of data. Okay, now we will not send any data, and we just hit send, and we switched on the red LED. Okay, this is how easy it is. Now, if you want to switch it off, you just change the peripheral command to set off, you send it, and you switch it off. It's very easy. If you want to talk to all of them, you just hit FF, which means broadcast. We will put the peripheral command again on, you just send it, and all of them are shining now. Okay, so this is how easy it is to then work with the DPA protocol. You just choose the peripheral number, peripheral command, you add your data, you send it out, and that's it. You don't take care how the message is delivered. Okay. You can also observe what is going on in the terminal log. So the communication is working in the 3 phases actually. The first one is the request. This is the request from the IQRF IDE to the coordinator. Okay, hey, do this and this. Then you have the confirmation from the coordinator. So yes, I received your request and I've done it. And then you can see the response from the module, from the node actually. So when you there's a difference when you send a message to a specific node, you get a response. When you send a request as a broadcast, you get only confirmation. You don't get response from all of the nodes. Then you would have to use a specific FRC command. So this is how you use it. This is how you communicate to actually, let's say, send commands. If you want to read data, you can send the same command, or what you can do, you can use what is called FRC. I will show you how to get the FRC, and also I will use this macro. So here you have a preset up macros for the coordinator node, so basically for all of the peripherals, and here you have also FRC. It works in the way that, let's say I want to get 1 byte temperature from the temperature sensors that are on the modules. Okay, so I hit this button, get temperature, and this command line gets filled in automatically. Okay, so you can see that I'm communicating with the FRC. Command is 00, and here in the data is actually the specification of the FRC command. I send it out, and there was a request response, and in the less than 1 second I got the response, and here you can see the temperature on my 5 modules in hexadecimal. With the double click on here, you can get to this what is called packet inspector. Okay, so here you have the packet in very detail, and also here you can see the temperature on my nodes in Celsius. So you can see it's pretty hot here. 27. This guy has even 30 degrees. Is because he's on the programmer. All right. So this is how you work with the modules, with the network. This is how you send commands. This is how you receive. And by the way, the FRC is very effective tool for downloading such a kind of data, like 1 byte data from the network. It takes much less time than do it in the standard polling. So maybe I would make a short stop here. Do you have any questions here?
So far, there is no question, so we can go ahead.
Okay, perfect. So I hope that's because it's so clear what I'm talking. It's not because that you gave up this seminar. So now let me show you how you can do the same, but from the internet, from the IQRF cloud. So basically, what you need to do now is to connect the gateway to the IQRF cloud. How you do it, it's very easy. You would use the gateway tool. Here is the right button for that. Or you can go to the tools and gateway tool. Okay. Here you write the username. The username is, the predefined username is IQRF. Okay. The password is the same. So again, IQRF. You get login, and now I get connected to the gateway. Currently, we have an error here, which is not good. So now I have a proof of claim that this is not a fake. And I would be very surprised if there wouldn't be any such a trouble. Okay, perfect. So now we are connected to the gateway GSM02. If you want to change the password, the username and the password, you can do it right here. Okay. There are a number of windows. You can go through them yourself. I will show you just the key things that you need to do during the first setup. First of all, you need to copy the ID. This we will use when we are registering this gateway to the IQRF cloud. Okay, so I hit copy ID. Now I have it stored, and now I can go to this window basic. Okay, here you will fill in the APN of your provider. Okay, so usually it's internet or something like this. And here, if your SIM card is close by the pin, you would fill in the pin. Here is pre-set up how often the gateway gets connected to the cloud. here we have the minimum for the GSM, the 10 seconds. Okay, here is that the gateway gets connected directly to the IQRF cloud server. Okay, if you buy the license, you can untick this and fill in your path or path to your server. So we will use the IQRF cloud. You will just hit uploads, and basically that's it. If you go back to the status window, here you can check the status. You see server communication, checking IQRF data. This means that everything is working well, and we are successfully connected to the IQRF cloud. Okay, so we close this, and now we can disconnect the GSM gateway. By the way, so far we use the gateway as a USB gateway. Now it's fully independent and it's working as a GSM gateway. Okay, and we go to the internet and to the IQRF cloud. So the address is cloud.iqrf.org, and the first thing you need to do is to register. So you would register here, your email, password, and so on and so on. You would save it, and you would get a confirmation email. Okay, there's a link that you must click on, and then you would fill in here your login information and your password, and you get logged into the IQRF cloud. Now you need to add the gateway. Yeah? That's the first thing you need to do. So here is the button for that, add gateway. Here you will with Control V insert the ID, and as you remember, the password is the IQRF. Okay, very easy. Now we hit save, and our device has been registered. Okay, so now we can see that the gateway is gateway 11. We have the access. This is the IP address. Here you can edit the name and the password if you want, and here you can remove the gateway from your list. So now we have the gateway ready, and we can check the data log. So this is the data log of the gateway. Here is the index, when the message was received by the server, when the message was received by the gateway, if the message was RX or TX. By the way, you can also filter this just to show, for example, RX packets. And here you have the data length, and here are the data themselves. You can display them in ASCII or hexadecimal. Okay, so the last column is the status. There are actually 3 statuses, and those are actually for the TX messages. One is confirmed, or first one is not picked. That means that you sent a request from the IQRF server, but it was not picked by the gateway. The second is sent, so it was sent to the gateway, and the third one is confirmed by the gateway. That means by the coordinator back to the cloud, and then usually you get a feedback. So now I will show you how it works in practice. That will be more visible. So we hit here on this send packet, and here you can type in your DPA command. Again, here we have couple of macros, so we will do the same. We will read the temperature on our nodes with the FRC command. Okay, you can see that it's the very same command. The only difference is that there's there are dollars between the bytes. You write in the IQRF password, that means the IQRF, and you just send it. Here you can see the statuses, which is not picked. Then it will be sent. I try to upload it. It gets connected every 10 seconds. So now we have the send. Okay, so it was sent from the IQRF cloud to the gateway, and now we have it confirmed by the gateway back. In a short while, we get also the response. And again, here you can see this 5 bytes of the temperature in my room. So now we are communicating from the IQRF cloud through the gateway, then through the IQRF network and back. And you saw that I spent last 10 or 15 minutes setting up this. Yeah? So it's very, very easy. So when you are, let's say, experienced, you will do it in 3, 4, 5 minutes, no problem. Okay, from the very beginning till setting up the whole communication from the IQRF cloud to the gateways, to the transceivers. Sorry. So now I guess you don't want to send the commands directly here from the IQRF cloud, right? You want to do it somehow automatically from your website. So that's why there's a specific API. Again, like the IQRF Cloud manual will be available on this download section of the IQRF web page. So you can download it later on when this will be released. By the way, it will be released definitely till the end of this year. And then you can use the API. I will show you just one example how to do this. Here I have the command again to read FRC temperature from our network. Okay, so I communicate to the cloud.iqrf.org. Here is my user ID. Here is my user password, very original one. Here is a gateway ID. Here is the gateway password. Here is the command to upload. And here is the command to upload data. And again, this is the very same command in the DPA protocol. So now I will just send it. It's sent to the cloud. Maybe we will see here that that it came. It was not picked. Then it will be sent to the. Now it was sent to the gateway. It was confirmed, and I will get a feedback very shortly. I guess if everything works well. Yes, everything works well. So now I go to feedback. Here we can see the temperature. And now when I want to download it, I will use a little bit different command. The command is basically the same. The only difference is that now I want the command is not upload but download, and I want to download the very last log. So when I hit this, I will get the same data that I saw on the IQRF cloud. So basically, this is the way how you can control your wireless network, your wireless products directly from your website. And as I said, not only website, but also, let's say, PC application or even Excel sheet. So from Excel, you can send these kind of commands. They go to the cloud. From the cloud, they go to the gateway. From the gateway to the IQRF network. Okay. So again, this is something which simplifies your development extremely easy. To give you an example, we had a application to measure temperature in the huge logistics centers. Okay. The only thing what the company needed to do is actually to take this kind of evaluation board with the module, with the temperature sensor. They put it around the logistics center. They upload the hardware profile there, the standard one, and they developed a very, very simple website that displayed the temperatures on the different nodes, right? And then they send just a command every 1 hour, whatever. They download the temperature and they display it, right? So this whole application, the development of the application took maybe 1 day, 2 days, and they have it fully up and running, and they did what they needed to do. Download temperature in the logistic centers couple times a day. Okay, so that's how easy it is to work with this. Do we have any questions to this topic?
Sorry, I have one question that when we lose bond, but I don't have any more specifications to this question, so.
Say it again, how was it?
When we lose bond.
When we lose bond. Okay. So I don't know exactly what this is meant with that, but I guess that actually when let's say one device stopped working, right? We have a street lamp, for example, and one of the lamps is not working anymore. So we can see that the node is lost. This is exactly what I will show you in the let's say 5 or 10 minutes, how to use what is called as a CAT service tool. So actually we can get connected to this node remotely find out if it's completely dead or if it's working somehow, if it's just, let's say, broken, and do some kind of things when we are connected to this node. So this is what I will show you shortly. Before that, let me show you how to work with a custom DPA handler. First of all, I will show you.
Sorry, Simon, we have one more question. May I?
Sure, go ahead.
What happens if one of nodes will go out of range?
All right. The question, if it goes out of the range, then basically you cannot reach it. Okay. That's why the topology should be that every node should see more than, let's say, 2 neighbors. Okay, so when it gets out of the range from one neighbor, it's still visible for another neighbor. And then the full mesh topology that we have, and that I can explain later on how it works in detail, is basically that the message, if it cannot be delivered through the node number 1, let's say, it will be delivered through the node number 2 and 3 as well. So basically, you will get the message anyhow. But if it gets out of the range from all of the neighbors, then it's basically lost, and you will not get the feedback from this node, and you will not be able to control it. So that's also why the power or TX power during the discovery should be lower than you use in the standard operation, because then the topology is set up in the more robust way.
Okay, thank you. And one more question. Are separate network members going to relay packets to other networks?
Could you repeat it, please?
Are separate network members going to relay packets to other networks?
Actually, it works in the way that first of all, you have a network, and the ID of the network is based on the module ID of the coordinator. So actually, you cannot send messages, let's say, from one network to the other. Okay, or out of the network, you cannot understand the messages. If you, let's say, want to send a message from the node number 3 to node number 5, it cannot be initiated by the node number 3. Okay, it's all the communication in the IQRF network is initiated by the coordinator. Okay, so standardly it works in the way that you send the FRC command to find out if any node has a, let's say, something to say, and then you realize that yes, number 3 has something to say. You would download it from the node number 3. You realize it's a message for number 5, and you send it to node number 5. But there's no direct communication from the node number 3 to node number 5. Yeah, and as I said, if we have enough time later on, I can explain in detail how the IQRF network operates, and this will be pretty visible. That basically this could be done only in the way. So the main message is every communication in the network is initiated by the coordinator, not by the node.
Okay, thank you. So I have a couple more questions. The next one is, if the node will go back after going out of range, will the topology heal itself and start working properly?
Actually, the topology will not change. If the node, let's say, goes out of the range and then it comes back, it immediately, when it hears the packets going around, it will immediately work with them. Okay, so there's no self-healing process. Basically, if the node is in the structure, and if it can hear the packages, it can hear it, and it can work with that, and it can transmit it also as well, like route it. And if it cannot hear, basically then it's out of the range. But there's no self-healing process. It will work immediately. This is also for the case when you, for example, switch off the whole network. Okay, so you don't have a power there at all. You switch it on, and in an instant, I mean like in, let's say, tenths of milliseconds, the whole network is up and running and ready to communicate. Okay, so there's no, let's say, restructuring the whole network. If the nodes don't move, if they don't move from one place to the other, then you don't have to run the discovery again, and the network can run immediately after reset.
Okay, may I continue with questions?
Sure, go ahead. Yeah.
Okay, so I have a question about cloud. Is it possible to set up a transceivers and send data automatically?
Not the transceivers themselves, but what you can do is to upload. I will show you here on this map. So basically, you can upload a specific custom DPA handler to the coordinator, and the coordinator can automatically, without any commands from the IQRF cloud, download the data from the network. Okay, so it can do it, let's say, every 5 minutes, just the coordinator. And then from the cloud, you can send the command and download this collected data, let's say, every 1 hour. Okay, so it wouldn't be done by the transceiver itself, but it would be done by the coordinator. And for this, you would need specific custom DPA handler.
Okay, what is the maximal distance between the nodes allowed by the protocol? How is the distance related to power consumption?
Okay, so definitely the range depends on the environment. Right, so different range will be on the open air, different range will be in the blocks of flats, right, where you have a lot of concrete and so on. So in general, talking very general, you have, let's say, hundreds of meters using the TR or DCTR 52 or 50 something or 70 something, and tens of meters indoor. So hundreds of meters outdoor, tens of meters indoor in general. And then it depends what kind of power you use to send the messages, right? So as I showed you here in the configuration, you can set up the TX power if it's 7 or 6 and 5. But let's say this will definitely change, let's say, the consumption of the energy. But the main thing, usually, what changes the consumption of energy is the listening. So if you are listening all the time, it consumes some energy. If you're just listening, if you use sleep, for example, that the whole network is sleeping for 1 hour, then you listen, communicate, you download the data, and then you sleep for another hour, then the consumption will be completely different. So then it depends on how often you need to read the data, and this is something we can help with to, let's say, decide what kind of concept would be used.
Okay, thank you. One more question is: it's possible to add a backup of database inside the coordinator?
Yes, this is something I will show later on. Okay, so yes.
Okay, and some other question: what is the sleep current, please?
Say it again.
What is the sleep current, please?
Okay, the sleep current is around 1 or 2 microamps. Okay. So this is very, very low, 1 or 2 microamps, and this is with Watchdog running, by the way. That means that you can set up, we have very precise sleep. So basically, you put the module on sleep for, let's say, 1 hour, and based on the Watchdog, the module is woken up exactly in 1 hour. Yeah, the difference is around 0.1%, so it's very, very precise.
Okay. Is it possible to auto-adjust the PX power to save battery?
You can do it in your custom DPA handler. Okay, the custom DPA handler is like your C language application, and whatever you write there, the module will behave in that way. Okay, so I can imagine a protocol that will use, hey, listen the RSSI, something like this, and based on this, he can change the TX power. But that would be pretty complex. And as I said, I don't think that the TX itself like change the power too much. It's really rather about listening in most of the applications, I would say.
Okay, so far there it was all of the questions, and we can go ahead.
Okay, so based on the questions at the very end, if you still have time, I will show you how the message is transmitted through the whole network. So then you will understand why we don't need the self-healing and so on. Now let me show you again in practice how you can upload the custom DPA handler. Okay, so as I said, here's the microchip bits that we have on the module. Okay, the basic is the operating system. So this is something which is burned into the module during the manufacturing. Then you have the layer of the hardware profile. This is something that we uploaded before. And now there's the custom DPA handler. And the custom DPA handler is the last layer. And here you can write basically whatever you want. It gives you the flexibility to modify the operation of the whole module. So let me now show you how to work with this. So we go to the IQRF IDE and we connect the gateway again. So now we go to the project and we will find one of the examples of the custom handler. Okay, so here we have custom handler examples. Those are in the starter package, and we will choose it. Let's say use a peripheral. Okay, I open the C code, and we can even take a look in the C file. So here, actually, what is written here is that we will do a new peripheral number 20, that will do the thing that if you send the command switch on, it will switch on both of the LEDs that are on the module, the green one as well as the red one. Okay. Here is the very simple code, and here you can see, for example, lights on. That means LED green and LED red on. Okay, off is the same. So that's basically the code. There's one more important thing, and that's the thing is that you cannot add a new peripheral with the demo hardware profile. So actually what you need is the full what is called general hardware profile, and this could be downloaded from the website. Again, you would go here to the download, and here you would download the general hardware profile. By the way, the demo hardware profile works on the TR modules, so standard transceivers. The general hardware profile works only on the DCTR modules. That's the difference, okay? And the demo hardware profile is limited. It's limited up to 5 nodes, and also not all the custom handler events are allowed there. So now basically what we need to do is to, first of all, we need to compile this. So we can hit F10 or this button. So I will hit F10 and compile it. So now I have it in a hex file, and now I need to add the general hardware profiles, okay, that I have here available. So I will do it for the coordinator and for the node. Okay, I open it, and now I need to change also the DPA configuration. And why we need to change the DPA configuration is because we need to enable custom DPA handler. And that's very important. Otherwise, the custom DPA handler wouldn't be called. Okay, so I close this, I save this, and now I have connected the gateway GSM02. Okay, in the gateway GSM02, I need to upload only the general hardware profile for the coordinator. That's the only thing, and let's say, yeah, the configuration. So this is what I need to upload. I hit F5, and I get it uploaded. Okay, so now I'm going from the demo hardware profile to the general hardware profile. Okay, so this is what I'm doing. This is what I'm doing right now. Later on, what I will do, I will upload the hex file to the, with the custom DPA handler to the node, and I will upload their general hardware profile for the node, and again the TR configuration. Okay, so now we have it successfully in the gateway GSM02. By the way, you can see that the the data regarding the network didn't disappear. Okay, even I changed the hardware profile, the data are still stored there. So I can still use the whole network without any bonding again and so on. Now I will switch to connect to our CK. So that's this module, and into this module I will upload the Custom DPA Handler. I will upload the node hardware profile and the configuration. Okay, so I hit F5 and it will get uploaded there. So actually I will have this new peripheral only in the node number 5. So now it takes time. It doesn't make sense to do it with all of them. Yeah, now we have to wait a little bit. If you don't mind, I will drink a cup of cold coffee. Now, okay. Excellent. So we have it there now, and now we can test it. And basically, we uploaded it into the node number 5, right? Now we have to choose the peripheral number, which is peripheral number 20. And the peripheral command is, let's say, 01 to switch on. Another thing is that I have to switch to the GSM 01 or to the gateway, which is our coordinator basically. So now if I send it, I switched on. I'm not sure that you can see it, but I switched on both green and red LED. Okay, so now I can switch it off. Okay, on the node number 5. So I added a peripheral. So this is how you use basically the Custom DPA Handler. Okay, you can use our examples. You modify them in the C language. You compile them. You upload them. You need to use, let's say, general hardware profile. You enable it in the DPA configuration, and that's it, right? Then you can do, for example, as we discussed, that the coordinator downloads something himself. Yeah, every 10 minutes he downloads the data, for example. Now, so this is how you work with a Custom DPA Handler. If you have any questions, please write them. And if we have some, do we have some questions now?
Yes, we have. Hold on just a second. The DCTR model can be used as a time master.
I'm sorry, I've got really troubles to hear you.
Okay, the DCTR module can be used as a spy master. Can you hear me now?
Not really.
Okay, so in Q&A question, there is this question from Mr. Darcy.
That's here, the chat, or?
In a Q&A window. The DCTR module can be used as a spy master, SPI master.
As a CI master, I don't know what this means. This is chat. How can I get to the QA?
Just unfold this button, this arrow. Click on this arrow, and you can see at the bottom.
Okay. And which one is it?
The last one, unread. Spy a protocol to communicate with other sender. From Mr. Darcy. At the bottom, the last one, 2 left. Can you see it?
Is it on the top? Or?
On the bottom. 2 with in the box.
No, I cannot see them basically.
Okay, hold on. I try to copy to chat. Now can you see it?
The DCTR module can be used as a SPI master. Now maybe my colleague will correct me, but I don't think so. No, it's a SPI slave. Yeah. So you actually send the commands from your control software through the SPI to the coordinator, and the coordinator works as a SPI slave. And Jaromir, if I'm wrong, please correct me. SDI protocol to communicate with other sensors. Yes, absolutely yes. You have if you have your node, the transceiver of the node, one of the peripheral is the SPI, so you can communicate through the SPI with, let's say, the sensor. Okay. So that should be the answer.
Oh, okay. So check. So far, all of the questions were answered, so we can go ahead. I have no more questions right now.
Okay. So I go ahead. Fine. Previously, there was a question regarding. Okay. So if there are any questions, you can put them into the chat. Okay. I can see the chat. So there was a question how to do the backup of the network. Okay. What you can do is to go to this table view on the IQ Mesh Network Manager. Okay, and here you can run what is called enumeration. Get enumeration. During the enumeration, the coordinator communicates with each node separately and download all the information about the node. Okay, so the enumeration can take some time, especially for the big networks. It can be actually tens of minutes. Okay, but then you will see all the details regarding the node. So not only, let's say, the MID was the VRN, so virtual routing number was the zone, what was the TR module, but also the build, the DPA version, the RSSI, supply voltage, and so on and so on. Okay, but you can go also in the detail hitting this plus, and here you will see all the information about the TR configuration. That means the operating system. Okay, what's the hardware profile, if we have a routing on, and so on and so on, and also standard peripherals that are available. Please take a look here on the node number 4. We are ending with this thermometer. Okay, this is the last peripheral. If we go to the node number 5, where we have the custom handler, we have the user peripheral here. Okay, so this is the peripheral that we added through the custom DPA handler. So not only that we can use it, but you can download it through the enumeration as well. Okay, so now you have all the information about the network available, and now what you can do, you can save this. Yeah, you can save this as a, let's say, this network 1 IQRF map. So you just hit save. Yes, we want to replace it. And now you can, anytime, without being connected to this network, you can open it. Okay, so you can open it again, and here you can see all the information, all the data again, but in the gray color. The gray color indicates that you are working offline. Yeah. So this is how you can download the data about the whole network for your file database. Here you can also download it into the, or you can export it to the different files, right? So that's definitely one of the first things that you should do when you have your network up and running. Okay, you run the discovery, you go here, and you download the information. Then we are also preparing the function backup and restore. Okay, and this will work in the way that you back up the whole network. Actually, it's already available here. That you can back up the whole network, and then you can actually back up the whole network or the coordinator. And if the coordinator burns out, you can take any other module, change the MID, and actually upload the backup to the module and put it back into the place of the original coordinator, and it will work immediately without any rebonding, rediscovery, and so on. Okay, this is something we are currently working on. This should be released till the end of this year. Okay, so you can see that it's already prepared here in the IQ Mesh Network Manager. Now we are just setting up how you would get the MID. Okay, so this is regarding the backup and restore. Now, if there are no questions, I would continue with the service of the network. If you use the standard IQRF transceivers, then you would have to create your service tool yourself. If you use the DPA or data control transceivers, then you can use this cat service tool. Okay, we will use again our node number 5. This is what I need. So this node number 5, and we will create a cat with this. So we will just hit. We will not do it on the gateway, but we will connect it to the CK-USB04A. Close. Now we are connected to the CK-USB, and we will create cats. Okay, so that now there's a plugin for the cats to be created. We want to have it on the 868 megahertz. Okay, so the plugin is uploaded to the module, and now the cats could be used as a one option is as an RF programmer. Here you can set up the parameters, or the second option is the DPA service. The RF programmer works in the way that now, if I send this hex files, plugins, or TR configuration, they will not be uploaded into this module, which is connected, but it will be sent out to the air. Okay, and all of the modules that are around and that are in the RFPGA mode, so wireless programming mode, would be uploaded with this hex, plugins, and TR configuration. Okay, so this is the RF programmer. Here you can set up the RF programming parameters like channel, power, how many times the packet should be repeated. The second option is how to use this DPA service. Yeah, the DPA service serves for the thing when you want to get connected directly to a certain node. Okay, so again, let's say you have installation in your building, yeah, and on the ceiling there's a light, and the light is, let's say, not working, and you want to get connected to this specific light. Okay, so what you would do, you would create this cat. You would come in the direct range of that module or of that device, and you would go to this DPA service. Okay, here we have some authorization file. This is a DPA service manager. Here we have device info and DSM scanner. Now I will show you how to use this. First of all, we don't want that any guy who is going by will connect to our network, right? So we need some kind of security there. The first security is the vendor ID. The vendor ID is a 2-byte number, and this is something which is burned into the module during the manufacturing. So actually, you as a customer, you ask during your order, hey, we want the modules with this and this vendor ID, or we will tell you which vendor ID you will get. Okay, because maybe you would ask for the same vendor ID as another customer. So actually, you will get the vendor ID, and this vendor ID cannot be changed later on anytime. Okay, so this is something you've got, and you've got on all of your modules. The second code is this USEC, user security code. Here it's preset as FFFF, and this USEC is pretty flexible. So actually, you can change it with a standard DPA commands. I can try it, or I can do it here. So what I will do, I will change back to the gateway to our gateway, and now I will send to the node, let's say number 3. To the node number 3, I will send a command to the operating system and set USEC. Okay, so I will tell him a new USEC that should be used. We are using Little Indian style, so if I want 1, 2, 3, 4 as the code, as the USEC, I need to send 3, 4, 1, 2. Okay, so now I send it, and I go to the terminal log, and I see that there was a response, so everything should work fine. So now I go back to the cat service tool. I go back to the CK-USB04 where we have the cat, and now I need to set up the USEC 1, 2, 3, 4 here. Okay. Now there are actually 3 ways how you can connect it. The most simple thing is that you select the first available module. So actually, you hit connect here, and then you reset the device you want to communicate with. Okay. And now we are connected to the module. And here we can see in the device info, we can see again the whole enumeration of the module. So TR module, what is configuration, and also here what is the address, that is address number 3, as a VRN, and so on and so on. So here you have all the information about the module. Okay, so that's one way how to connect there, and this is in the case that you are able to reset this specific device. Yeah, that's not always the case, right? Sometimes you can only let's say reset all of the device that you have in let's say one network. Okay, so the other option is that you will connect to a specific MID. Okay, the MID we have here from the previous communication from the DSM scanner and here in the MID list. Okay, so now I want to connect just to the module with this specific MID. So I hit connect. Okay, it's waiting, and now I can reset the node number 1. This will not be connected. Number 2 will not be connected, but the node number 3 will get connected. Okay, so this is something what could be expected sooner or later. Okay, now we get connected to the node number 3. Okay, so this is the second option how to do that. The third option is that you have no clue what kind of modules are around. Okay, so I just get disconnect again, and what you can do is the scan MID. So actually you can let this running, and you can scan the whole communication which is going around, and let's say scan all the resets. Okay, so then you can see all the 4 MIDs of the modules that are around, and then you can connect to one after the other. Okay, so now we can get connected to this module again, to this our node number 3. And one thing is that we can here indicate the DPA device that we communicate with. Okay, with this red LED. So you see that it's working. And here you can set up the TR configuration. So again, except the RF band, you can set up everything here. So the operating system as well as the hardware profile, the peripherals you can add, you can change the TX power, RS filter, whatever, right? And you just upload it wirelessly. We are still working wirelessly from our CATs to the specific module. Okay, so that's one thing. The second thing is, or that's one of the things. Another thing is that you can do the wireless programming. Okay, so you can, if you hit this, it actually puts the module, this module number 3, into the RF DGM mode. That means that now it's listening for a new file to be uploaded. By the way, this CAT gets automatically switched into the RF programmer. So now, if I select this, let's say, custom handler, okay, and I hit F5, this custom handler will be uploaded into the node number 3 wirelessly. Okay, so now I've got it there. Okay, by the way, the wireless programming mode is switched or terminated automatically on the mode number 3, and now we got disconnected, so now we can connect to the module again. Okay, so that's how you can use it for the wireless programming, of the specific mode, of the specific node. Sorry. You can also unbond the node. Okay, so let's say now we are connected to the node number 3, so I will unbond it. Yes, I'm sure, and you will see that the node number 3 will start flashing. Now you can see it, but it's flashing here. Okay, the DSM mode was terminated. Now you can see, I guess. Oh, yes, yeah, the number 3 is flashing now. So the module was unbonded, but the important thing is that it was unbonded only on the node side. Okay, the coordinator is not aware of this. So when I go to the GSM02 and I go to the IQMesh Network Manager and I get this refreshed, the coordinator still thinks that number 3 is there. Okay, that's pretty important. So you do the unbonding only on the coordinator side. Another thing what you can do in the CATs is bonding. Okay, so here is the bonding button, and it actually serves in the way that you run the bonding on your coordinator, so it's listening, and instead of pushing button directly on your evaluation board or on your device, you can just hit the bond right here. Okay, so you do it wirelessly. It actually means that you don't have to have a button on your device at the end of the day. Okay, so here the last thing are backup, restore, and set MID. Those are things that are still, as I mentioned, being prepared. So this will be available, let's say, till the end of this year. So basically, this is how you can use the servicing. This is how you can use CAT, and this is a very strong tool, especially when you have, let's say, a larger network that you need to service. You can come to a device and wirelessly get connected and change firmware, upload new things, bond, rebond, okay, and so on. Change the configuration and so on. Okay, so this was regarding the servicing. Do you have any questions to this?
Hold on, let me check.
I can see here. Question: CATS must be bonded to the network previously or not? No, actually, CATS is not bonded. Okay, CATS is independent tool, and with the CATS you can connect to any network. If you know the vendor ID and the user. Okay.
So far, there is no question, so we can go ahead. Hello?
Okay.
Okay.
Excellent. So, one more thing. Let me very briefly explain the SDK. Okay. So now we will be talking about this part. Okay. Java-driven device, IQRF SDK. What we have ready. Okay. So I have a very short presentation. This is something we will not show in practice. So basically, you want to control the network from some kind of hardware. It could be PC, server, embedded PC, as a Raspberry or flat PC, whatever. It can also run on. That's not working. Okay. It can also run on Windows or Linux. It doesn't matter. Okay. And one common thing of these devices is that they all support Java. Okay. So this is also the reason why we developed the IQRF SDK on Java. So basically, it's extremely flexible, and you can work with any kind of hardware and operating system. So basically, when you integrate SDK into your hardware, it's basically a Java library, and you can select what kind of functionality you want to use from this. The SDK will create IQRF DPA commands. Okay, and these IQRF DPA commands will be sent through a different type of interfaces. It could be USB CDC class, it could be a UART, it could be an SPI, and Ethernet. Okay. By the way, this is only a matter of configuration. So basically, you can have your software running, and then you just decide, I will send it through the UART, or I will send it through the SPI. It's just a matter of the configuration. You don't have to change the coding. Okay, and then you can communicate to different networks, to different coordinators, and the coordinators will translate it into the wireless packet and send it through the network. Okay, through the nodes, the network. You can, in that case, you can use predefined peripherals as the custom peripherals. So you can use the Custom DPA Handler as well. So this is basically the concept, and with this, one of the great thing is that the standard Internet of Things clouds and databases have also Java libraries. So then it's very easy to connect these kind of clouds. It doesn't have to be necessarily IQRF cloud, but it could be any standard IoT cloud, and you can connect it to your hardware where it is running the SDK, based on the Java. Okay, so then from any kind of cloud or database, you can send through your hardware commands to the IQRF network and back. So this is actually then it's working in the same way as I showed you previously with the IQRF cloud. Okay, so this is basically how the SDK is developed, it again should dramatically simplify your development. And this is something which is, let's say, released currently only based on request, so it's in some kind of evaluation period. And again, till the end of this year, it will be fully released and available for everyone. Okay. So if you have any project right now, and this is something which would help you, please get in touch with us, and we can discuss if we can provide this to you. Okay. Do we have any questions at this point?
Yes, we do. So, but Jaromir already answered it. Do you plan to introduce a higher security version that could be used for intrusion alarm system with the vendor read and USEC could just scan through the combination with brute force? But Jaromir actually answered already that not currently.
Okay. Okay. Thank you.
Okay, so we can go ahead.
All right. So this is actually pretty much all from the practical point of view. Okay, from the IQRF IDE and so on. Since we had questions regarding the networking itself, I would spend next let's say 10 minutes maximum on the explanation how the network works actually. So I will explain the IQ mesh protocol, which is based on the IQRF network. So basically, this could be a network that you have ready or that you are using: street lighting, indoor lighting, home automation, whatever. Okay. Here are the basic parameters. So first of all, you can run on 868, 916, and 433 megahertz. There are 62 different numbered type of channels for each of these bands, and we are working on 19.2 kilovolts. Okay. It's full mesh topology with always one coordinator, and we can have up to 239 routers, or actually nodes. Each one of the nodes can, but doesn't have to be a router. We show that you can switch the routing off very easily. Okay. Then you can have up to 239 sub-coordinators. So basically, each of these modules could be a sub-coordinator. That means you can have also 239 sub-networks, and this means that you can have thousands of nodes in one network. Like, having said that, it's not recommended. Definitely, to have the network more flexible, it's better to keep the network reasonably, let's say, 200 nodes. And it's usually better to rather place there more coordinators than to have like one huge network. In each network, you can have 240 hops. Each of these hops takes between 30 and 50 milliseconds. All of what I'm talking here about is regarding the DCPR, okay, so using the DPA protocol. So 30 to 50 milliseconds per hop, and you can transfer 56 bytes in one bucket, okay? As I mentioned previously, the communication in the main network is synchronized. It's synchronous communication. In a minute, I will show you how the packet is transmitted, okay? So that's why actually you can use the subnetworks, and subnetworks are usually used for the asynchronous communication. It means that, for example, this number 1 is a remote controller. You push the button here, and it sends the information directly to this node, and let's say switch on the light immediately. Okay, and then let's say with a FRC, you download if the light is switched on or off. Okay, so this is the let's say the way around how you can have very fast reactions from the remote controllers. Regarding the range, indoor tens of meters, outdoor hundreds of meters. Then it strongly depends on the environment. Okay, we are preparing this page IQRF.org/RF simulation, and here you will be able to simulate your conditions, and based on that, the range will be calculated. Okay, so how you do this? How you actually set up this kind of network? First of all, you have modules So those are shown by this gray bullets, and each of these module has unique 4-byte module ID. Okay, this 4-byte module ID is especially important for the coordinator, where you upload the hardware profile for the coordinator, and based on this 4-byte module ID, the network ID is set up. Okay, then you have the nodes, and to the nodes you upload the hardware profile, and if you want to have this, as we call it, schizophrenic node, that means it's a node and coordinator at the same time, you need to upload the coordinator node hardware profile. All right. So then you need to do what is called bonding. So assign it with the logical address. So this is what we saw in practice earlier. And let's say if you want to bond node in the subnetwork, you would bond it to this coordinator. Okay, to the sub coordinator. Let's say we want to have these nodes number 1 and 4 without routing. Let's say they are running on battery. So you switch the routing off in the TR configuration, right? This is what we mentioned as well here. So now the next step is that you place the modules on the final destination, and you run the discovery. Okay. During the discovery, you set up what is called virtual routing number. Okay, so the coordinator actually asks, hey guys, who can hear me, let me know. There will be node number 3, 6, and 4, or actually only node number 3 and 6 who will reply. Number 4 will not reply because we switched the routing off. Okay, and then the coordinator will assign number 3 with the routing number 1, because it's lower, 3 is lower than 6. So this will be routing number 1, and this will be routing number 2, and that's all for the zone 0. Zone 0 means that you can get there without any routing hops. Okay. Then the coordinator asks the node number 3, hey, please find anyone who is around and assign him with a VRN higher than 2. Okay, so he will discover number 2, and the VRN will be number 3, and number 6 will discover node number 5, and the VRN will be node number 4. Okay. Number 1 will not be discovered because the routing is switched off. Okay, this is the zone number 1 is completed. So this is what is done during the discovery. Okay, so that's why if I go back to the so I managed to get back somehow. Yeah, if I get back to the IDE and to the IQRF Network Manager, those are the numbers. Okay. This number 1 is a logical address, and this lower number is the virtual routing number. Okay, so this is how it's related to the presentation. So now the question is how it's all working. So it's working basically on the time slots. So in the time slot number 0, the coordinator sends a message, let's say a broadcast message to all of them. Okay, and it's delivered to the node number 3, 6, and 4 in the time slot number 0. Then in the time slot number 1, it's only the node with the VRN1 who transmits the packet farther. Okay, so then it's received here, here, and even back here on the coordinator. Then it goes the module with the VRN number 2, and so on. Okay, so then it's routed with this module and with the module number 4. Or with the module with the VRN number 4. If the packet goes back, it's the very same, but it's going like vice versa from the node number 4, 3, 2, 1, and so on. Okay. Based on this, or this explanation will then answer a lot of your questions that you have recently. Okay. So this is called directed flooding, and as you can see, there are a lot of redundant packets that are delivered to the node. For example, here. This node received the message 1, 2, 3, 4 times even. Okay, so the probability of losing packets is very, very low. Okay, there's no need for self-healing. Yeah, so if there was a question, if this module gets out of the range, and if we come back, it can immediately work again. Yeah, so he receives the packet, he knows his time slot, so he will transmit it in his time slot. Yeah, end of story. No need of self-healing. And also there's a minimal latency after reset. This is also what we mentioned. So basically you switch off the whole network, you switch it on, and in a matter of 10 milliseconds, you will have the network up and running. No self-healing process. The nodes remember their VRNs. Okay, if you want to calculate how much time it takes to deliver a packet, we multiply time of the hop, okay, which, as we said, is like 30 to 50 milliseconds, time number of the hops. So in this case, it was like 4 hops, so 50 milliseconds times 4, it's, let's say, 200 milliseconds, yeah, to deliver the message to the node number 1. If you want the whole communication, that means also with the response, you have to multiply it by 2. That's very simple. One of the huge benefits of this directed flooding is that even if we have a lot of communication links lost, the message will still be delivered. In this case, we have 5 nodes or 5 links out of 11 lost, and the message still will be delivered to all the nodes. Okay, this is how the message will be communicated throughout the network. Okay, so even almost half of the network is broken, or the links are broken, and still the message is delivered. Okay, so it's very robust way of working. So this is how the standard communication is, and now let me show you how the FRC works, because that's one of the key feature that we released recently. And the problem with this, let's say, directed flooding is, and it's usually the case of all of the mesh networks, is that when you want to do the polling, the time of the polling grows exponentially based on number of the nodes. So here's the number of the nodes, and here is the time in seconds, how much time it takes to pull the data. Okay, so for 10 nodes, it's just 3 seconds, but for 100 nodes, it's already 300 seconds, which means like 5 minutes. And for 239 nodes, it's already 1700 minutes. That means almost half an hour. Okay, so that's why we developed FRC. And the FRC works in the way that you send a request, and then basically on the way back, each of the node adds his data, or this 1 byte or 2 bits, and add it into the communication and send it back to the coordinator. So basically, then you can, then you have these kind of times. And for 10 nodes, it's just 1 second. For 100 nodes, it's 12 seconds, and for 239 nodes, it's 29 seconds. Okay, so that's like 30 seconds instead of 30 minutes. Okay, so this is a huge difference. You can actually send 2 to 30 bytes as a command there, and you can collect 2 bits from 239 nodes. That's one option. This is for the cases when you want to ask the question yes or no. Like, do you have a new message for me? Yeah, is everything okay? This kind of question, yes or no. So you get 2 bits, or you can download 1 byte. This is what you can do from up to 62 nodes, and this is what we used when I was downloading the temperature from my nodes. Okay, so those are the options, and now I will show you how it works. So there are actually three sections, or 3 types, or 3 steps. That's the word. 3 steps of the fast response command. The first one is to deliver the query. Okay, this takes around 50 milliseconds per node. The second step is to send out data from each of the nodes, okay, to all of the neighbors. So it goes from the highest module, or from the module with the highest logical address to the lowest. So each of the nodes sends his data to all the neighbors, and then the last router creates the packet. Okay, he fills it in with all the data it has available. So in this case, it's we have the data for node number 1, for node number 2, then for node number 5, which is this one, and for node number 6. Okay, and this packet is sent out, and actually it's delivered to the node number 6 and to the node number 2. Okay, the node number 2 has also the information for the node number 3. So he added here and send it further, okay? And here, number 6 will add also the information of the node number 3, and he had also the information of node number 3, so he sent it to the coordinator. And in this way, you get all the data from the whole network, okay? And data collection takes, again, like 50 milliseconds per node. So this is the FRC, how it's working. There are a couple of FRC pre-set up, which is like pre-bonding. This is for when you do the remote bonding. Then you can download data if you have data on UART or SPI. Acknowledge broadcast. This is a very, I would say, great feature, because you can send a broadcast, like switch on the lights, and like a broadcast command, and you would get a feedback. Okay, you would get a FRC saying, hey, this light switched on and this light didn't. Okay, so this gives you like a feedback when sending a broadcast message. That's very important. This is not the case for the standard broadcast messages. And then there's a preset up temperature FRC. This is what we used previously, and you can definitely create your own one with the Custom DPA Handler. Okay, so this is the fast response command. Maybe very last information regarding asynchronous commands. The asynchronous commands, if you have a center unit and you have a switcher, okay, so those are two things. You create a subnetwork. So you want to control this light. Let's say this is a light, and you want to control it from the center unit, but from the switcher as well. Okay, so you create a subnetwork, and the main network is working on one channel, and you put the subnetwork on the different channel. And this is what I was talking about in the RF configuration. Okay, and then right here, okay, the second network. And then when you come to the switcher, you hit the button. The message is delivered directly to the node. The light is switched on, and then the center unit will ask with a periodic FRC to get status. Hey, yes, I'm switched on, I'm switched off, or whatever. Okay, so this is for the local control. You can also send the broadcast commands with feedback. Yeah? So basically, that's it. This is what I wanted to cover on this webinar, and where we are heading to is basically, again, to make your products wireless simply. You know, so you have your products, you know what you need to create, and we are here to help you to make these products wireless. Connect them to your control unit, or connect them to your website or Excel sheet, and the only thing what you should be focused on is your device and is your control software. The communication between should be completely covered by the IQRF. As I mentioned, some of these things that I was talking about will be released shortly. Our deadline is the Electronica in Munich, which is in the middle of November. So let's say till Christmas, everything should be ready and available for you to use it. Okay. If you need anything from this already now, please get in touch with us, and we will see if we can provide this to you, let's say in some kind of early adopter program or not. So make your product wireless. It's simple. Do you have any questions?
Okay. We have one question. What is the largest network number of nodes that is implemented by the IQRF nodes?
Okay. The largest network I'm aware about is with like 4,500 nodes, and this is indoor lighting application in a shopping mall in Mexico. They are not using the DCTR, they are using old modules, even the B modules, and it's still working for like 4 or 5 years without any trouble. So this is the biggest installation, 4,500. From my perspective, it's a little bit crazy, but it's working well. So I would definitely recommend to keep the network on, let's say, few hundred nodes.
Okay, so it seems that all the questions were answered.
All right.
So if that's it, let me thank you for your presentation.
Thank you. It was my pleasure.
And also, I would like to remember all of our attendees, please be so kind and fulfill for us a short survey at the end of this webinar. Just let us know how we did, what to improve, what is good. As I mentioned also at the beginning, there is a special offer for development kit from IQRF, and I will send all of information about this promotion via email, so you will receive all information, and this offer is valid till 17 September. So if you are interested, just let us know and order this development kit. And so far, it's everything from my side, and let me thank you one more time for your attention and for your time.
Okay.
And
can I have one more thing, please?
Yes.
So basically, the things that I've shown today will be prepared in the format of video tutorials. So what we prepared over the summer is like 12 video tutorials, which will guide you from the beginning till through the setting up the network, using the network, servicing the network, using the SDK, and so on. So this is something which will be released, I believe, at the end of October, and this should help you to, let's say, come back and check, hey, how I can unbond the nodes, or how I can bond them, and so on. So this should give you a very clear idea how to use the IQRF. So you can definitely check this webinar, but you can also later on check these videos. They will be available on YouTube and on our website, and I believe on the websites of our distributors. So from my side, the last thing, good luck with your development, good luck with your business. Thank you very much.
So thank you very much. And as was mentioned, all this presentation will be also available at SOS Web in 1 week. So you can go through and see it one more time. It will be ready also. So one more time, thank you very much for your attention, and have a nice day. Bye-bye.
Thank you. Bye-bye.